I'd like to spend a few minutes and talk about exponential decay structure. Previously, I've talked about um, stock independent growth and balancing loops and reinforcing loops. This is a particular situation wherein the goal is actually less than the current state of something, and as a result of that the difference between them creates a gap, wherein the gap is the impetus for action, resulting in a decline in the current state, moving it toward the goal. So that we're typically for a goal-oriented structure, it's the structure attempts to move the current state in the direction of the goal, and it's an increase because the goal is greater than the current state. Though for an exponential decay, the goal is actually less than the current state. And the characteristic behavior that results from this is distinctively different than what you find when you look at the behavior over time graphs for a goal-seeking structure. Now, if we look at the stock and flow equivalent of this diagram, we've added an action factor simply to control the rate at which that action migrates the current state in the direction of the goal. So if we run this with some initial values, notice that the current state begins where it was, and it declines over time, and it declines toward the goal, the desired state, and it therefore produces this characteristic exponential curve. It's like an exponential growth curve lying on its side or rotated to the left by 90 degrees, so that as time progresses, it declines slower and slower as it approaches the goal. Now, oftentimes this goal is zero. Consider the decay of radioactive elements, where each time period it loses half of its radioactive nature, and it's continuing to decline towards zero. Though there are cases where the goal is something other than zero, but it's good to realize that the time of the behavior over time graph for an exponential decay, while it's still a goal-seeking structure, looks very different than the curve that you see for typical goal-seeking structures, which is the sort of the rotated inverse of this, where it begins and goes up like this and approaches the goal over time in this direction. So it just wanted to take an opportunity to show you what the behavior of an exponential decay structure looked like, and that the structure looks the same, but the behavior curve looks very different. So this model is available, and you can go ahead and access it and play with it and change the factors and run a number of simulations until you get a feel for how the behavior of the structure differs from the other goal-seeking structure. Now, this model is actually an element of the Insight Maker simulation learning module in Kumu. The link to this is in the notes section of the video, and this particular element, which was contributed by Edith Thompson, is there. You can watch the video, access the model, and interact with it. So hope you found this of some interest and utility, and I'll see you in another video soon. Bye.